Shalom to you. In this video, I would like us to look at the trigonometric identities, which we use a great deal. We use a lot in pre-calc and in calculus. So you need to master them, and you can only master them by using them to solve problems. The more you use them, the more familiar they become to you. But you need to know these trig identities, okay? And I believe if you know how those identities come about, it will be easier to remember them. Okay, they have them on this table, page 283 from your textbook. Okay, and let's just go back to the unit circle. Started with derive some of these identities. So you have the unit circle. Again, unit circle is a circle with radius 1. So from the center of the circle to the one side of the circle is the radius, so it's 1. So every radius here from the middle to the circle is a radius. So from here to here is a radius. So each one of them is 1. They are all 1, 1, 1. But then if we draw, this is angle theta. If we draw a vertical line down here to make a right angle, that cuts this line, this part, into 2 segments. So from here to here, let's name it x. If we name it x, because it's less than 1 now. So okay. So call me x because it's a horizontal line. Horizontal goes with x. And then this side, vertical, then we name it y. Okay. And that gives us a right triangle. So with angle theta, and this is the hypotenuse. Hypotenuse is facing the right angle. Hypotenuse is 1. So if we find sine theta, okay, sine theta is going to be opposite. Again, remember the SOHCAHTOA. So SOHCAHTOA. So sine is opposite over hypotenuse. Sine is opposite. So a line opposite, side opposite the theta is y over the hypotenuse, which is 1. So y over 1 is actually y. So cosine theta, cosine is adjacent over hypotenuse. So and side adjacent to this is going to be x. It's x over hypotenuse again is 1. So this cosine is actually x. And then tangent, tan theta is opposite over adjacent. So it's y over x. So that gives us something here to work on. So we can see that actually that sine theta is simply equal to y. And cosine theta is x. And tan theta is y over x. And so cosecant theta is going to be the reciprocal of y, reciprocal of sine theta. So that's going to be 1 over y. And secant theta is going to be 1 over x. And cotangent of theta is going to be x over 1. So because they are both reciprocals of each other. Okay. So then we can use substitution to get more equations from, since we know that sine is y, cosine is x. So we can actually get this triangle out of this. Just draw it without unit circle. So we can see that. So y is sine theta. So we can actually replace y here with sine theta. but this is hypotenuse is always 1. So, and x is cosine theta. X is cosine theta. So we replace this side with cosine theta. And if you notice that if the theta is here, so sine is the opposite, cosine is the adjacent side. Okay. So we can then write some of these. Alright, then let's look at what we have with these identities. So we see here, let's start from maybe the cosecant. The cosecant was 1 over y. Well, we know that y is sine theta. So if we replace sine theta with y, that's cosecant theta is 1 over sine theta. See that? And then secant theta is the same thing. Secant is 1 over x. X is cosine. So if we substitute that for cosine, we get that. And then cotangent is the same thing. Cotangent is 1 over tan theta. So of course we have the tan is reciprocal of cotan. And then sine is a reciprocal. Sine is reciprocal of cosecant. Cosine is reciprocal of secant, and so forth. And we can get the inverse, the quotient one. Tan, since tan here, tan is y over x. So it's y over x. So sine is y. So sine theta over x cosine theta. So that's how we got this one. Sine over cosine. And cotangent is the reciprocal of this. So just flip it. So for Pythagorean identities, so think of this, if we use Pythagorean theorem to set each of these sides. So this is one is hypotenuse. So if we have the two legs, so cosine theta squared plus sine theta squared is going to be 1 squared, because 1 squared is 1. So and sometimes we just simplify this to remove the parentheses, we put the square here. But you know these two expressions are the same. So okay, so that's it. That's the Pythagorean identities. Okay, another equivalent expressions we need to help you solve problems faster is recognizing things that are equivalent. For example, if we notice from the table we created last week, so sine 30 is 1/2. We notice also cosine 60 is also 1/2. How are they related? Well, sine and cosine, you see 30 and 60 are complementary. They add up to be 90. So when you have two complementary angles of sine and cosine, they are going to equal each other, because some angles on a triangle has to add up to be 180. So the same thing, if you notice that sine 60 is going to equal cosine 30 also. So I thought that cosine 30. See that? Okay, so then again, because of the same reason, sine 45 is square root of 2 over 2. Cosine 45 is also square root of 2 over 2, because 45 plus 5 is 90. Then it has to go between sine and cosine. So tangent and cotangent do the same thing. See, they don't have tangent here, but you have it on the table we created. So you have that one. So okay, so watch for those. So they have this summary for you down here on page 282. So that is just saying that when you have a sine angle complementary to sine, complementary angles of sine and cosine, that they are equal. The complementary angles of tan and cotan are equal. Complementary angles of secant and cosecant are equal, and so forth. Okay, let's see how we use that to solve problems quickly. Right here they ask you to use the given function values and the trigonometric identities to find the indicated function. So they gave us sine 60 to be that, square root of 3 over 2. They gave us cosine 60 to be 1/2. Okay, so how do you use them and then find tan 60 right away? Well, let's look for any complementary angles. Sine 60 will be complementary to cosine 30. We have cosine 30 here, right there. So C. So C right away is going to be cosine 30 is going to be the same thing. It's going to be square root of 3 over 2. Okay, because they are complementary, sine and cosine 30 and 60. So cosine 60 is going to be complementary to sine 30. We have sine 30 here, that's B. Okay, I'll just do sine 30. So cosine 60 is going to be 1/2 as well. I mean, what am I saying? Sine 30, sorry. Or equals to sine 30. Yeah, they're going to equal. So that's 1/2 also. Okay, so and then what else can we? How else can we use that to find tan and cotangent? Of course, if we find one, he can help us find the other. So let's look at tangent. Well, tangent tan 60. Okay, tan 60. Okay, tan 60 degree. We know that tan is from the identity. Since both of them are 60, 60, the angles are 66, it makes it easy because tan is, remember, opposite over adjacent. And opposite, so it's going to be sine 60 over cosine 60. Sine 60, because this is the same angle, is going to be tan 60 is going to be sine 60 over cosine 60. So since we know tan 60, sine 60, which is square root of 3 over 2 divided by cosine 60, which is 1/2. So once we have them stack up like that, we can just write them like square root of 3 over 2 divided by 1/2. So that will be square root of 3 over 2 times 2 over 1. So it goes out, we have square root of 3. So tan 60 is going to be square root of 3. But then cotan 60, cotan 60, because cotan is the reciprocal of tan. So since we have tan, reciprocal of tan is going to be 1 over square root of 3. Okay, so we get one, we use it to find the other. But then we cannot leave square root on that denominator, so we have to multiply this by square root of 3 over square root of 3. Okay, so that becomes square root of 3 over 3. Alright, so that's how we use that to solve problem quickly. And let's look at another example quickly. They gave us cosine alpha is 1/3. Okay, and to find secant alpha, so if we don't have any direct, we can look at the identities. So any connection between cosine and secant. So we have cosine and secant. See this one? So if we use it to substitute, we are looking for secant. So if we substitute for cosine, so since we know that cosine theta is equal to 1 over secant theta. Okay, so then we have cosine theta, we substitute cosine theta for 1/3 here, equals 1 over secant theta. And then we can solve for it. The equal sign can cross multiply, so secant theta will actually be 3 times 1, it's going to be 3. Okay, so that's it. So sine theta, we look for any connection between cosine and sine. Okay, cosine and sine. Yeah, well, we know cosine and sine are 90, we have sine 90 minus alpha, which is its reciprocal. So it's going to actually be cosine alpha. So this is cosine alpha. This is cosine alpha, which is the same thing as 1/3. Okay, see how that, so I'm going to stop here because the video is getting long. I hope you get the idea.